Okay, so we want to start looking at different angles again. And so we're going to start by looking at adjacent angles and also then vertical angles. So an adjacent angle, well, let's have some intersecting lines. So, if I want this line to look like that. So here I have two lines that are intersecting. And we can see that four angles are formed. The 1, 2, 3, and 4. So if I want to look at which two angles are adjacent angles, adjacent means next to each other. So adjacent angles are going to be angles that are formed by two intersecting lines and that share a common line or a common side. So if I look here, if I look at this angle, and then I look at this angle, notice that right down here in the middle is this common side. So I would say that these two angles are adjacent, much in the same way that this angle and this angle have this middle common side. So these two are adjacent angles. So we could say this is 1 and 2. Angles 1 and angles 2 are adjacent, as well as if I have angles 3 and angles 4. Angle 3 and angle 4 are also adjacent. So the key is that these angles share a common side. And they can't have any common interior points, but just focus on this. Now vertical angles, so let's again draw some intersecting lines here. So I have two intersecting lines. Vertical angles are non-adjacent angles. So basically they do not share a common middle side. So if I look at this angle here, and then this angle, opposite is a good way to describe it, we can see that there are four rays coming off of this point. No one of those rays is the same. So that means that these two angles here, so here I can say this is 1 and 2, angles 1 and angles 2 are vertical angles. Just as with those intersecting lines, I could also look at this angle here and that angle there, and we can see again they do not share a common side. So if I call this angle 3 and this angle 4, then angle 3 and angle 4 are also vertical angles. These are two of the most common angles we'll be working with. So make sure you understand the difference between vertical angles and then adjacent angles. Adjacent angles, again, have that side that they share. Vertical angles don't share a side. And sometimes it's helpful to highlight or write over the angles, just like I did. Now there's also the idea of a linear pair. Pair means two. So if we have, well, pair means two, and then linear, well, we could see line in that. So a linear pair is nothing more than two angles that make up a line. So here if I have this angle, so I call that angle 1, and then I have this angle, which I can call angle 2. Angle 1 and angle 2 are a linear pair because they are a pair of angles that make a line. and it's important that they must be adjacent. So technically, angles 1 and 2 are adjacent angles, but a more specific adjective is a linear pair. While technically we're not wrong if we say adjacent, we need to be as specific as possible when we talk about angles. Much in the same way I could say, somebody is European, but if I say that they're French, that's more specific. And we want to be as specific as possible with these angles. Now this you may have seen before, complementary angles. So we have complementary angles and supplementary angles. So complementary angles, let me draw it like this. Complementary angles will add up to 90 degrees. So these add to 90 degrees. So if I have this angle here, and I say this is angle 1, this is angle 2, then angle 1 plus angle 2 is equal to 90 degrees. And we can see that they do make this right angle for the two of them. Now it is important to note we could have multiple angles in here. Complementary angles don't have to be just two angles. I can have multiple angles adding up to 90 degrees. Supplementary angles, supplementary angles add up to 180 degrees. So if I have two angles there, we can see I have an obtuse angle and I have an acute angle. Say this is 3 and 4. Angles 3 and 4 make this straight line. They're actually a linear pair. So supplementary angles add to 180. And we can see that a straight line is going to be 180 degrees. And since supplementary angles add up to 180 degrees, we can say that a linear pair are going to be supplementary. Now the reason we don't call these, the reason we have this word supplementary is, again, just like complementary angles, we can have multiple angles that add up to 180 degrees. So here I have 1, 2, 3, 4, 5, 6 angles. They are all supplementary. However, they're not a linear pair because a pair only means two. So let's look at some applications and some examples of problems that we can look at and do. So I have this diagram and it says that measure of angle RTS is 8x plus 8. So 8x plus 18. We want to find the value of x so that ray TR is perpendicular to ray TS. Well, if they're perpendicular, that's going to mean that this is a right angle, which means 90 degrees. So, for number 9, I'm going to have that 8x plus 18 must equal 90 degrees. And I solve for x. So I can subtract the 18 from both sides, and that's going to leave me with a 72. And then I can divide 8 on both sides, so I get that x is equal to 9. For number 10, they give us that angle PTQ, so PTQ is 3y minus 10, and the measure of angle QTR is just y. I want to find the value of y, so that PTR is a right angle. And yet again, that right angle means 90 degrees. So if I look, these two angles here are complementary. And complementary angles add up to 90 degrees. So if I add these two angles, 3y minus 10 plus y, I should get 90 degrees. So I combine my like terms to get 4y minus 10 is equal to 90. I get 4y is equal to 100, and then I can divide by y to get that y is equal to 25. So understanding how to set up the equation is important, and that's just a matter of solving. We have some more problems here we can do, and here we see these squares, and again these squares mean right angles, 90 degrees. So if the measure of angle FGE right there, is 5x plus 10, find the value of x so that FC is perpendicular to AE. Well, we can already see that this is 90 degrees, and if they're perpendicular, that's also going to mean 90 degrees. So for number 7, we can set up that 5x plus 10 must equal 90 degrees. So if we subtract 10 from both sides, we get that 5x is equal to 80. And then we can divide both sides by 5. So if I divide both sides by 5, I'm going to get 16. So x must be equal to 16. For number 8, I'm given that angle BGC, so BGC right in here, that's equal to 16x minus 4. And CGD is equal to 2x plus 13. We want to find the value of x so that BGD is a right angle. We can see that right angle right in there. Well, if BGD is a right angle, then these two angles are going to be complementary, meaning they're going to add up to 90 degrees. So if I take these two angles and I add up the values, and set them equal to 90, I have a nice equation I can solve. So I combine my like terms. 16x plus 2x is 18x, minus 4 plus 13 is plus 9. And then I can subtract 9 from both sides, so I get that 18x is equal to 81, which I'm not sure if that goes in evenly, but that's okay if I get a fraction. So I'm going to get that x is equal to 81 over 18, which 81 is the same as 9 times 9, and 18 is the same as 9 times 2. So I can cancel out those 9s. So that means that x is equal to 9 halves. We get a fraction. I didn't need a calculator, and that's okay. So that's it. So we see some algebraic approaches where we have these angles and we have to solve. Now, no equations are given. We need to set up equations. And we set up the equations by understanding the relationships between complementary, supplementary, linear pair, vertical, and adjacent angles. So make sure that you understand what these angles are, the relationships, and you can use that to help you set up equations.